as you might imagine, continues on with square roots. And this is a very foundational thing as you move forward into Algebra 2, geometry, pre-calc sort of a class. So radicands that are not perfect squares, you can use a calculator like we've done, or they can be reduced to a simpler form. One of the ways that you can use to do this is to use prime factors or factor trees.
I love this, actually.
I do too. I think it's kind of fun.
Yeah, me too.
So this is almost like reducing a fraction. This is reducing a radical into its lowest, simplest form. And so a good example of this, we'll probably just do one or two of these examples, would be the square root of 12. You guys can look at 12. It's a low enough number. You probably look at that and you say, all right, that's definitely not a perfect square, right? What are the closest perfect squares to 12?
3 and 4.
Yeah, 9 and 16 are 3 and 4, right? Yeah, those are the closest ones to 12. And so here's what we could do. We could use a calculator, but sometimes that's not what we want to use. We're going to try to simplify this without using the calculator. Here's one way you can do this. You guys watching? This is one of the methods your books teaches. I like this method. Here we go. We're going to do a factor ladder or factor tree to break 12 down into its prime factors. 3 times 4 would be a good breakdown. 3 is prime, but 4 is not.
2, bring out a 2.
2 times 2, right? So 4 is really 2 times 2. And so those, we've done this a couple times this year, those are the prime factors of 12. So here's what we would do with this. Check this out. I would rewrite root 12 then to be 2 times 2 times 3. I have not changed the value. I've done anything to it really at all other than change the form into the prime factors instead of just a 12. Now here's how this works as far as the square root goes and simplifying it. As you look at your list of prime factors, you're looking for pairs of identical twins essentially. So as you look through there, can you see how the 2 and the 2 are obviously the same number, right? You have a pair of 2's. And here's how this works. With that pair of 2's, if you've got a pair of 2's on the inside, they can come out of the radical as just a single 2. So this would simplify to be 2 times the square root of 3. Here's what's really happening though. What's 2 times 2?
4.
And what's the square root of 4?
2.
That's right. So to get the 4 out, it has to be square rooted. That's really what's going on here. So the square root of 4 is 2. So the root 12 is really 2 times the square root of 3. If you want on your calculator, you could confirm this. You could go square root of 12 and see what the answer is. And you could do 2 times the square root of 3 and see what the answer is. And you'd see that they're the same thing. It's just a lowest form. It's like the difference between 3/6 and 1/2. Let's do one more here. Let's do number 2. Jake, question?
It says simplified, so would the answer be the 2 radical 3?
It would.
Or
Yep.
would it be the actual, like, what is it, like 3, 4, 6?
Already answered your question. It would be the 2 radical 3. If I wanted you to use a calculator, I would say use a calculator round to the nearest tenth or something like that. Yep, good question. Okay, let's do one more here before we go. And it would be number 2. This says simplify the square root of 200. So in order to do this well, have you guys already done the prime factors?
Yeah.
Some? Okay. So Avery, 200. What numbers did you have to go into 200?
10 and 20.
10 times 20 makes sense. Let's piggyback off that. Are either of those prime?
No.
Danny, how would you break down the 10?
5 and 2.
Agreed. So 5 times 2 works. And then
200. Yeah, I did it right.
the 20 could be broken down into 2 and 10. Okay, so 2 times 10. And then finally the 10 would be like before the 5 times the 2. So our prime factors are all here and here. So this one goes a little bit differently. This is the square root of 200. It's really the square root of 2 times 2 times 2 times 5 times 5. So again, we're looking for pairs of identical twins. How many pairs of 2's do you see?
1.
There's 1 pair of 2, but isn't there a leftover 2?
Yeah.
How many pairs of 5's do you see?
2. 1.
There's 1 pair, there's 2 5's, yeah. So the way this would work is this pair of 2's gets to come out of the radical as a 2. The square root of 4 is 2. And then this pair of 5's gets to come out of the radical as a 5. Yeah, square root of 25 is 5. So it'd be 2 times 5 times square root of? The only one that didn't get to come out was this 2, so that's left in there. So let's say, before you pack up, say your final answer would be 10 times the square root of 2.
Wouldn't we just be quicker to do split it up in 2 and 100, and then you know that?
You can. That's an alternative method. It is. It is a good method as well. So, all right, we'll practice this a lot more tomorrow. Have a wonderful afternoon.